Hello students, how are you? I hope you are doing well. Today I have come up with four questions from mechanics. I have picked these questions from the first shift, morning shift of 25th January 2023 JEE mains. So let us start. Here is the first question. An object of mass 8 kg is hanging from one end of a uniform rod CD. This is D. Of mass 2 kg and length 1 meter, pivoted at its ends on a vertical wall as shown in the figure. It is supported by a cable AB such that the system is in equilibrium. The tension in the cable is. Now students, if you draw the free body diagram of the rod, then see, look at the forces acting there. The weight of the rod is 20 into G. The weight of the 8 kg block is 8 into G. G is 10 meters per second square, so 80 Newton. Then you have the tension in the string. Let us take it as T, which we have to find cable. Now the most important thing is that it is pivoted here. A pivot is basically a hinge. You can call it as a hinge. So it will have two reactions, one horizontal reaction and the other vertical reaction. So H is the horizontal reaction, V is the vertical reaction. Okay. Now let us resolve all the forces along horizontal and vertical directions. So this angle is 30°. So this component will be T sine 30°, and this component will be T cos 30°. So I have replaced this tension of the cable with the help of its two components, one horizontal and the other horizontal and vertical components. Now, if we consider the horizontal equilibrium and vertical equilibrium, then we'll have only two equations. Whereas, as you can see, there are three unknowns. What are they? We don't know T, we don't know H, and we don't know V. So there has to be another equation, because three unknowns means you can solve them only if you have three equations. One equation you can get from the fact that the rod is in horizontal equilibrium. The other condition can be obtained by the condition of vertical equilibrium. But still you have one more condition left. That is, you have to apply the principle of moments. That is, if it is not rotating, if it is in rotational equilibrium, then about any point in the plane, total clockwise moments must be equal to the total anti-clockwise moments. That is known as principle of moments. So basically, when you apply the condition of equilibrium, make sure that the body, if the body is in both kinds of equilibrium, namely translatory as well as rotatory, then translatory equilibrium can be obtained by applying the condition of horizontal equilibrium and vertical equilibrium if the body is under the influence of only coplanar forces. On the other hand, if the body is under the influence of three-dimensional forces, then we have to apply the condition of equilibrium along each of the three principal axes, namely x, y, and z. That is, along any three mutually perpendicular directions, right? Then again you have to apply the condition of rotational equilibrium as well. So here, by applying condition of rotational equilibrium only, you can get the third equation. So since we are interested only in T, calculating T, so let us take the moment of the body about this point C and apply the condition of rotational equilibrium, that is clockwise moments equal to anti-clockwise moments. So when you calculate the moment, you don't have to calculate the moment of force due to this component of tension, that is horizontal component of tension, horizontal reaction at the hinge or the pivot, and the vertical reaction of the pivot. So we are left with what? The vertical component of tension and the two weights, that is weight of the rod and the weight of the 8 kg block. So applying condition of rotation equilibrium, you can see weight of the rod and weight of the block, they apply clockwise moments, whereas the vertical component of tension applies anti-clockwise moment. Moment of forces due to these forces shown by green color will be zero because their lines of action pass through this point C, about which we are about to apply the condition of rotation equilibrium. So about point C, about point C, clockwise moments must be equal to anti-clockwise moments. So clockwise moment is due to the weights. So 20 Newton into this distance is 50 cm because it's a meter rod. So 50 cm plus moment due to this 80 Newton into 100 centimeter. Meter rod, the length is 1 meter. This should be offset or balanced by the moment due to this force, that is T by 2 multiplied by 60 centimeter. You can see the distance is 60 centimeter, the lever arm. Okay, right. So let us solve it. 1 0 gets cancelled throughout, and also you can cancel by 2 3s. So we have 3t is equal to 25 is 100 plus 800, that is 900. So T is equal to 900 by 3, that is 300 Newton. So correct answer is third option. Let us move to the next question. Question number 2. A car is moving with a horizontal speed of 20 meters per second in a circular horizontal track of radius 40 meters. A bob is suspended from the roof of the car by a massless string. The angle made by the string with the vertical will be. This question is based on rotational motion or circular motion, I should say. Okay. We will draw the free body diagram of the bob by taking the car as the frame of reference. If you take the car as the frame of reference, suppose the car is going this way along a circle of radius r. Okay, so the string will be like this. This is the roof of the car. We have to find the angle made by the string with the vertical. So here there will be a tension. Since we have taken the car as the frame of reference, car being a non-inertial reference frame because it is going along a circle, so it is in an acceleration, centripetal acceleration. So car is in a centripetal acceleration. So whenever we take an inertial reference frame, whenever we take a accelerating reference frame as the frame of reference, we need to include a pseudo force. That pseudo force will be mass of the object multiplied by acceleration of the reference frame, and its direction should be opposite to the direction of the acceleration of reference frame. Remember, the car has a centripetal acceleration towards the center of the circle. So the pseudo force must be away from the center. In fact, this is known as centrifugal force. Centrifugal force. So the bob is at rest because if you stand in a car and watch, if you stand in the car and watch it, observe it, you will find the bob at rest. So the bob is in equilibrium. Since the bob is in equilibrium, so what we can write is, we can draw the force diagram and we can see that it must form a triangle, a closed polygon of 3 sides. So this will be tension T, this will be mg, and this will be mv square by r. This angle is theta. Since we don't know about t, we are not interested in t, so let us not involve t in our discussion. So we can write tan theta is equal to perpendicular upon base. So gets cancelled. So this is the formula. So v is how much? V is 20 meters per second. Radius is 40 meters. The acceleration due to gravity is this. So exactly tan theta is 1. So theta is 45 degree or pi by 4 radian. So the correct option is the third option. Okay. Let us move to the next question. Question number 3. An object of mass m initially at rest on a smooth horizontal plane starts moving under the action of force F is equal to 2 Newton. In the process of its linear motion, the angle theta is missing here. The angle theta is shown between the direction of force and horizontal varies as theta equal to x, where k is a constant and x is the distance covered by the object from its initial position. The expression for kinetic energy of the object. So students, whenever you come across question based on kinetic energy, and if you see that a certain force is doing work on the body, always try to apply work energy theorem. So the work energy theorem states that work done by all the forces on the body results in a change in its kinetic energy. Literally, there is no exception to this rule. Okay, if you take a system or a body, draw the free body diagram so that all the forces acting on the body is very very clear. Then what you do? You find out the work done by all the forces and equate it to change in kinetic energy. Change will be calculated as final value minus initial value. So I write down work done by all the forces results in change in kinetic energy, which is final kinetic energy minus initial kinetic energy. So if you take final speed as v and initial speed as u, then you can write this. So this is work energy theorem. So work energy theorem is applicable here. So we have to find the kinetic energy of the object. Since it starts from rest, so initial speed will be how much? Initial speed will be 0. So therefore we'll have only half mv square. Isn't it? So this is the kinetic energy. So the final kinetic energy is simply the work done by all the forces. So for that we have to draw the free body diagram. So in the free body diagram you will see that there are only three forces. One is the weight acting vertically down, the other is the normal reaction vertically up. There is no friction because it is clearly given that it is a smooth horizontal surface, so there is no friction. So these are the three forces, and since the movement is taking place along horizontal direction, so work done due to these two forces will be 0. Work done by normal reaction and work done by weight will be 0. So you have only work done due to the force, and work done due to the force is, since the force is constant, you can write, but however angle is changing. So I'll write this as total of small work done by forces. So work done is F into dx into cos of theta. F is 2, theta is kx. So here x varies from, initially it was 0 and now it is x actually. So x varies from 0 to x. So therefore twice integral cos is sine kx divided by k integrated between the limits 0 to x. So finally we have 2 by k into sine kx after substituting the limits. So therefore the required value of n is 2. Required value of n is 2. I hope that is clear. Let us move to the fourth question. Coming to fourth question, ICM is the moment of inertia of a circular disc about an axis CM passing through its center and perpendicular to the plane of the disc. IAB is its moment of inertia about an axis AB perpendicular to plane and parallel to the axis CM at a distance 2r by 3 from the center, where r is the radius of the disc. The ratio IAB and ICM is x is to 9, the value of x is. So let us draw the diagram and understand the situation properly. So first of all, I have to draw a disk. O is the center. This is CM. Moment of inertia of the disk about this is ICM, which is equal to mr square by 2, where r is the radius. We all know this. Then the other axis is AB. This is AB at a distance small r is equal to 2r by 3 from the center. So we have to obtain the ratio of IAB to ICM. Now, since this axis does not pass through the center of mass AB axis, so we have to apply the concept of parallel axis theorem, which states that moment of inertia about any axis is equal to moment of inertia of the body about a parallel centroidal axis. Centroidal axis means an axis passing through the centroid. Centroid means center of mass, plus mass of the body into distance between the axes. Distance between the axes, I have taken it as small r. So as per the question, we have to find the ratio IAB to ICM. So IAB is, this is, remember, mr square by 2, this part. So we have mr square by 2 plus m into small r square whole divided by mr square by 2. Student, you could have observed that I have not substituted the value of small r here. Of course, that is one way. You can substitute small r in terms of capital R and simplify, but I usually prefer this way, the way I am solving. This will yield, if you divide this, you will get 1 plus 2 into small r by capital R whole square. I personally feel this is more easier to simplify. Small r by capital R will be 2 by 3, as you can see from here. From here, you can see small r by capital R is 2 by 3. So finally, you have 1 plus 8 by 9, that is 17 by 9. So x is 17. X is 17. Let us move to the next question. All the questions are over. So that's all for in this video, students. I hope you are liking my videos. Kindly subscribe to my channel and hit the like button. Okay. Thank you so much.